Don't forget to subscribe and ring that bell.
Hey, 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 hey. It is going to be a beautiful day in the Finger Lakes region of upstate New York. 79 degrees today in mid-April. God, it can't get any better. And maybe I'll go see John Wick 4 today. Can't wait. Although my daughter wants to see the Super Mario Brothers movies, which I'll make a concession to do so if need be. Anyways, you know what else is awesome? Math, mathematics, nay, calculus. And speaking of calculus, we are going to do free response question number 3 from a set of 2022 AP Calculus AB short answer problems. Okay, we do not get a calculator. Oh, okay. But you know what? As I say previously, before, as I always said, you know what? When we don't get a calculator, the math tends to be a little bit easier to do. I mean, we don't get a calculator. It should be. Let's start. Number 3. Let f be a differentiable function with f of 4 equals 3 on the interval from 0 to 7 inclusive. The graph of f prime, the derivative of f, consists of a semicircle and 2 line segments as shown in the lovely figure above. They want us to find f of 0 and find f of 5. So a couple of things that I always do when I get a problem like this is if I know this is the graph of f prime, my y value is the value of f prime of x. Okay, so whatever y is, that's the derivative value of f, or the slope. Okay, the second thing that immediately pops out to me is they give me this. Okay, that's normally a nice thing, like f of 4 equals 3. So I kind of get a coordinate of the original function. All right, so what they want us to do for part A is find f of 0. All right, and here we'll do that in red, and then find f of 5, which we'll do in green. So a key concept to calculus is, all right, we have f. I keep on doing that. I get the wrong one. I want to do this in black. We have f. Let's be professional, kids. Let's do it like this. We have f, we have f prime, and we have f double prime. These are all one derivative away. But if I go backward, that's an integration, okay? And here's the thing. I have the graph of f prime. I want the graph of f. So I need to go backwards, which means I need to integrate. All right? I need to go, it looks like a clown face. Anyways, sorry, I don't mean to get distracted. So I need to integrate. Okay, we're going to do this right here. I need to integrate, and again, let's do this in red. I need to integrate f prime of x dx, and that will give us the original function. All right, but now let's bring in bounds, okay? And this is a huge concept, all right? If I have bounds a to b, and I integrate, no longer do I have a function, but I throw the function with the upper bound in it minus the lower bound. And this is what we're going to do to solve these two, f of 0 and f of 5. So let's start. The only thing I see for f of 0, 0 has got to be my lower bound. Keep in mind, I have an interval that goes from 0 to 7. Okay, 0 is the lower bound, so we're going to call that a. So I'm going to go here, erase that, and put a 0 there. That's the lower bound, a. So what I got to do is put that 0 in here. All right. What do I use for the upper bound? Do I use 7? I don't know, but like I need something that has value to it because I'm figuring this out. This will still be unknown. I can't have another unknown. This is where f of 4 equals 3 comes into play. My other x value is going to be 4. So my upper bound, ooh, let's get rid of that, is going to be 4, which means the upper bound here is going to be 4. And believe it or not, we know 2 of these 3 terms, okay? F of 4, well, they gave us that. That's 3. minus, I'm finding out what f of 0 is. That's fine. I can integrate the above graph from 0 to 4. Remember, integration is area under the curve. So let's look at our graph. From 0 to 4. Okay, we'll go back here. You know I love me some highlighters. From 0 to 4. Oh, perfect. It's a half circle. It's a semicircle. The area of a circle is pi r squared. But I only have half that circle, right? So I'm going to multiply it times a half. My radius from the middle to the edge is 2. So that's my radius. So we got 1/2 pi times 2 squared. 2 squared is 4. Half of 4 is 2. So it's really 2 pi. Okay, that's it. That's the area of this semicircle, 2 pi, which means that's the integration. All right, well, let's subtract 3. Boom. I've got -3 plus 2 pi equals negative f of 0. Well, we don't want negative f of 0. I'm positive, so I can just flip the signs, or I can kind of say multiply both sides by -1. Okay, so I'm going to distribute that. So it's positive 3 minus 2 pi actually equals f of 0. And that's our first answer right there. Don't be afraid that it says 2 pi. We don't have a calculator. Don't sit there and say, make 2 pi, 6.28, and then, subtract that from 3. I mean, I guess you could. But anytime you don't get a calculator, it's not expected that you do that. That is 100% correct. All right, well, that's good. It's fine. It's a little bit on the dandy side. But let's do f of 5 now. And we're going to do the same thing. We're going to integrate f prime of x dx. Okay? And now I need f of 5. Okay? So I need f of 5. And they give me f of 4. So these are going to be my bounds. This is what I'm looking for. So I'm going to do from 4 to 5, which means, okay, if I integrate f prime, it gives me f from the upper bound minus f from the lower bound. Again, this is such a huge concept to just know and understand. It will pop up, definitely, multiple times. All right? Again, I'm trying to find f of 5 that will stay the same. Minus, we know this is 3, that's given to us. All right, well, let's just find out the area under the curve from 4 to 5. So let's go back up to our fantastic graph. Get a highlighter. We'll go purple. From 4 to 5. Oh, my goodness. It's just this little section of triangle here. Wow, it's a little dinky triangle. So a triangle is 1/2 base times height. Okay, my base is 1, and my height is also 1. Ooh, that's easy. 1/2, 1 times 1. That's just 1/2. So the area of that triangle is 1/2, which means the integration of that area is 1/2. Huh, man, now it's cake. A lot easier than f of 0. Let's add 3 to both sides. We have 3 and 1/2. But guys, this is calculus. Let's just call it 3.5. Either would be set. Either would be fine. You would get credit for both. But the answer key would probably make it decimal. Okay, there you go. 3A is done. 3B tells us, find the x coordinates of all points of inflection of the graph of f from 0 to 7, not inclusive, greater than 0, less than 7, and justify your answer. All right, let's analyze this here. Let's analyze this, y'all kids. Okay, points of inflection. That's where the second derivative not only equals 0, but then it changes signs. So it would go from positive to negative, or it would go from negative to positive. Okay, so that's where the point. I got to think second derivative. If I go up to this graph, I don't have the second derivative. Remember, I have the first derivative. I mean, it's right here, but I always write it there. I always tell my students to, so they associate the y value with the first derivative, all right? Okay, so how do I get the second derivative if I have the first derivative? I'm going to go back to the first one. Look at right here, children. If the second derivative is the derivative of the first derivative, that also means the second derivative is the slope of the first derivative. Remember, it's interchangeable, derivative and slope. Okay, so if I take the derivative of the first derivative, I get the second derivative, which means if I take the slope of the first derivative, I get the second derivative. So the slope of the first derivative is the second derivative. Okay, it's interchangeable. It's like saying taking the derivative of the first derivative is the second derivative. Absolutely 100% true. So I'm going to look at the slope of this graph, and the slope will tell me the second derivative. All right. So and just to tweak something here, okay, when we think points of inflections, we said it's where the second derivative is equal to 0. It could be 0, or it could be undefined, okay? It could be 0 or undefined, all right? So let's take a look at this graph, and let's see where the slope of this is either 0 or it's undefined. Okay, slope is 0 right here. Undefined right here, because that's a corner or a cusp. I'll call that a cusp because it kind of curves and goes to an angle. And this is definitely a corner right here. So it's undefined, undefined, 0. But keep in mind, I can't just say those three x values. I can't say 2, 4, and 6 yet. I also got to make sure the sign of the second derivative changes, which means the sign of the slope. Is it going from a positive slope to negative slope? Is it going from negative slope to positive? So again, we're looking at the slope of the first derivative. So negative slope, negative slope, negative slope, negative slope, 0. It does change there. Now it's a positive slope. So one of our answers is at x equals 2. So let's continue this. It's like approach 4. It's still positive. It hits undefined, but stays positive. So the slope did not change there, so it's not at 4. I'm going to X that out. So let's continue past 5, the x value 5, positive, positive, undefined. Then, yeah, then it does go negative. So it does change at 6. That's another point of inflection. Okay, so I'm going to state those. But again, justify your answer. I mean, justification is normally math work, but if you like kind of dice up the graph, do whatever, and explain it, you will get credit. Okay, so here we go. At x equals 2 and 6, justify. All right, and you could say this one of a million different ways. X equals 2, x equals 6 are both points of inflection. Okay, since the slope of the first derivative, or f prime of x, changes at those two spots or points or coordinates or x coordinates. All right, there you go. Justification. You stated what's what, and you justified it with your explanation. All right? Not too bad. 3C. Let g be the function defined by g of x equals f of x minus x. On what intervals, if any, is g decreasing for the x values between 0 and 7 inclusive? show the analysis that leads to your answer. Okay, that's okay. This one is really not going to be a lot of work at all. Let's take a look at this. Down here. Anytime someone is decreasing or something, not someone. I don't want anyone to decrease. Okay? Anytime something is decreasing, some function, that means the first derivative is negative. In this case, all right, this is g. So instead of saying f prime, when is g decreasing? So it's when g prime is negative. So the first thing I need to do is find out what g prime is. They give us g right here. Let's take the derivative of this. Well, the derivative of f is f prime of x. And then the minus the derivative of x is just 1. Okay. Now, I want that to be negative, so it's got to be like less than 0, right? Anytime that's less than 0. All right, well, here we go. This here. Let's take a look at this. Let's go back up to our graph. And this is why I always tell students, y is the first derivative. Okay, any y value. Let's take a look at this point right here that I'm putting in blue. See how the y value is 2? If y equals 2, that means the first derivative is 2. Okay, that's why it's important to know that. So let's take a look at our inequality down below one more time. Let's make this a little bit easier. I don't have the graph of f prime minus 1. I have the graph of f prime. So how about we just add 1 to both sides? So this holds true. F prime minus 1 is less than 0 anytime f prime is less than 1. Because I did the math here. I got rid of this. There you go. So I'm going to go back I have the graph of this. Let's look to see when it's less than 1. Remember, f prime is the same thing on the graph as y. So technically, that's the same thing as saying when y is less than 1. Because our graph is f prime. And that's why, I mean, some kids will get confused. That's why this just puts it point blank in your face. Here's the line 1. Anytime this graph is below that line, oh, dear my. Starting from 0, it's below, it's below, it's below, it's below, it's here, boom, it stops. From 0 to 5. That's it. That's it. Okay? So I'm just going to say, okay, let you be the function on what intervals? Between 0 and 5. There you go. That's it. Okay? That's it. You're done. Show the analysis. Here you go. This is it. When the derivative is less than 0, we do the math to set it up to refer to our graph, and then bang, there's our answer. You're welcome. All right. 3D. Oh, brings us back to the good old days of finding mins and maxes. 3D states, for the function d, which was defined in part C, okay? Remember, that was when g of x equals f of x minus x, okay? Find the absolute minimum value on the interval between 0 and 7, inclusive, and justify your answer, okay? Well, again, in order to find minimums, okay, I need to find the first derivative of g. I'm not going to say f this time. The first derivative of g. See where it's either 0 or it's undefined. Okay? And then I got to check the value of the slope or that derivative around that critical point. This is called a critical point, in case you forgot. Critical point. Okay? And if I want a minimum, I want a negative derivative to a positive, because that tells me the graph will be going down and coming up, and that's where I get my minimum. All right? So in general, in a nutshell, that's what we're going to do. It's a good thing if you were here for 3C, if you didn't just skip ahead to this, which maybe some of you guys did. In 3C, we found out that the derivative of g of x was just f prime of x minus 1. All right? So we got to figure out the critical points there. All right, we got to figure out the critical points there. So where is that equal to 0? Or if we want, we can solve that. We'll add 1 to both sides. F prime of x. When f prime of x equals 1, this holds true. Because if I put a 1 in for this, 1 minus 1 is 0. Okay, so let's figure out where f prime of x is 1. All the way up here. Okay, and I'm going to go right where x equals 5. Now I can go here. Okay, and I suppose I can check this part as well. It's an endpoint and see which one's lower. All right, so let's do this. I'm excited, kids. I'm excited. I'm going to put this on a number line. Okay? Number line. I'm going to put 5 right here. And my number line shouldn't have arrowheads because it goes from 0 to 7, doesn't it? In fact, it'll probably go like this. Goes from 0 to 7. How come? Interval 0 to 7. Okay? When x is these values below, g prime of x, well, I know that's when my first derivative is equal to 0 here. So I got to check some points in between. Let's check the points. I don't know. 1, 2, anything. Let's pick 2. And then here, let's pick 6. All right? And I'm going to check to see if the first derivative is positive or negative. All right? So g prime of 2 is like saying f prime of 2 minus 1. How did I know this? Because this is the derivative right here. Okay, so let's go to our graph and see what f prime of 2 is. F prime of 2 is negative 2. All right. Negative 2 minus 1. Well, that's negative 3. I don't care so much about the 3. I care more about the negative side. Those are all negative values. Remember, we want to go negative to positive, right? So let's try 6. Okay, let's see what g prime of 6 is. Well, that's like taking f prime of 6 and subtracting 1. Go back up to our graph. F prime of 6 is 2. Okay? 2. So let's go here. 2 minus 1. Well, that's a positive 1. Again, I don't care about the 1. I more care about the positive sign. So guess what? All right, the only place I can see a minimum here, my graph would be going down, hit a minimum, then going up. So I don't even have to check 7, okay, because it's here at 5. Okay, so find the absolute minimum. All right, here we go. Ready? So I know I can say, and please don't fall into this trap. Look to the left side of the screen here. There's a minimum at x equals 5. They're not asking me where it is. They want me to find the actual minimum. Remember, the minimum is a coordinate where there's going to be an x and a y. This is the location or the where. This is the actual value of that min or max. In this case, the minimum. I need the y value. So I need to take my 5x and put it into g. Okay, I got to put it into the original equation. Okay, so g of 5 is f of 5 minus 5. Okay, because look at, let me just rewrite this again. My original equation said g of x equals f of x minus x. That's the original equation. I always go to the original equation if I'm looking for a coordinate. Okay? And I just put a 5 in here. Okay? F of 5, God, where does that look familiar? Guys, let's go back to 3a. Look at the right side in green. Didn't I have to find f of 5? Wasn't f of 5 3.5? It was. We've already done this. You know, that's one thing I really like about these calculus exams. You can go back and use previous things. Okay, up, that. Let's go down here. Let's extend this. Okay, so get rid of this for a second. F of 5 is 3.5 minus 5, which is negative 1.5. That's the y value. That is the absolute minimum value right there. That happens at an x value of 5, but the low point is negative 1.5. All right? Again, I like that we go back and do that, but the problem is if you screw up 3a, it's going to be hard for you to get 3D right. I don't know how they take that into consideration as far as like if you use that number and all the math is correct per that number, maybe you get some sort of credit. I should really look into that. All right. But you know what? You're smart enough. You ain't going to mess it up anyways. We are done. We will see you later for free response question number 4. Thanks for hanging around. Bye-bye.
Don't forget to subscribe and ring that bell.